Hi everyone, and welcome to the What's New in Gradle 5.0 webinar. I am Jen Strader, the new developer advocate for Gradle Inc.
And I'm Eric Wendelin. I lead developer experience at Gradle.
So today we compiled a list of the top things in Gradle 5.0 that have kind of happened. I mean, some of them are from 4.0 and up, some are brand new in 5.0 that we think might make your build happier.
Yeah. And we will be covering just the new features and new APIs, but not really how to use Gradle. So if you want to know more about how to use Gradle in general, the best place to start is to go to gradle.org/training, where you can get live training, but then also with a mindset toward learning what projects are, what tasks are, and just generally how to compile your Java and stuff. We'll probably just rapid fire go through new features and things, and many of them might not make sense unless you've actually used Gradle a decent amount. So training and the docs are definitely the places to start there.
So today we assembled a list of kind of the top things that we think are exciting about the new Gradle 5.0 release. And those of course include that the Kotlin DSL went 1.0, that there have been some really interesting changes in build performance, and you have a lot of nice pretty graphs there to go over. As a longtime Spring user, there have been some changes to dependency management, which I found exciting, so I'm going to show a demo of that. And then for plugin authors, or maybe just people who are writing tasks in their own build scripts, there have been some changes to the APIs,
Yep.
right?
We'll cover some new APIs, show you some good stuff. It's exciting.
So let's start with the Kotlin DSL. So as a longtime Groovy user, before I joined Gradle, I thought, oh, I'm just going to keep all of my build scripts and all of my projects using the Groovy DSL. But I have recently seen a lot of new and exciting things, especially in the 1.0 release. Can you show us a little bit of what other Groovy users will want to know about the Kotlin DSL?
Yeah, so this is probably one of our most exciting things that we have in 5.0, and that is that the Kotlin DSL is finally production ready. We feel like it's finally ready to use. Before we had lots of previews that were good, but now it's really good. We've added documentation, we've added a bunch of improvements, bug fixes, and also type-safe task accessors and source set accessors. And I'm going to show you some of that stuff today. But in general, if you haven't heard about the Kotlin DSL, it's really all about IDE assistance. And the reason that the Kotlin DSL can provide better IDE assistance is because Kotlin is statically typed. And so IDEs and tools can infer a whole lot more about what's going on in the code. It knows what's a string, what's nullable, and so forth. It knows about these extensions, and it's really a whole lot better to see it. So I'm just going to go ahead and show you some of this stuff live by example. Let's see, I'm going to go ahead and make a new Kotlin project. Go to the directory. So I have a new directory, nothing in it, right? And I'm going to use the Gradle init because now in Gradle 5.0 there's a couple new nice things to show you. So I'm going to say Gradle init --type Kotlin application, which is new. So there's two new types in Gradle 5.0 strictly. So Kotlin application, and if I start this up, what you'll notice first is that it allows you to choose your build script DSL, Groovy or Kotlin. So I'm going to go ahead and choose Kotlin. It also gives me the chance to choose a project name or a package, and I'm just going to go with the default here. All right, so now I have a basic build Kotlin application that we can run. So this is what that init task has generated. And to really demonstrate how useful the Kotlin DSL is, you get a little bit of IDE assistance with repositories and dependencies, but it's really awesome when you have plugins. So I'm going to apply a custom plugin. So I'm going to apply the Gradle site plugin here, version 0.6. All right, and you can see that really quick little Nyan cat went across the screen and it's compiled already. Now I want to configure this site plugin, and so IntelliJ tells me, hey, there's this site extension, and now it's compiled. And IntelliJ, you can see here, it knows it's this site plugin extension. Okay, what can I configure here? So I can just hit Command Space, like you'd expect in every other editor, and I can try Output Doer, and it's a property. It's using the new property API. So I have to set it this way. It's expecting a file. So I say file, and I'm just going to do the builder site directory. Okay, and so now if I run the generate site task, it's going to produce this website that it'll generate into this directory. And again, what we can do is we have all our refactoring tools here. So I can hit Command-Alt-V and extract that to a variable and call it the site dir, right? And I can just move it around, and this is really what you'd come to expect from your editor. And again, this is what the Kotlin DSL is all about. Just to contrast that a little bit with what you'd be getting with Groovy, I'll just show you. I have the same type of Groovy project here, and we're going to go ahead and apply the same plugin, right? So Gradle.site version gives me a little bit of assistance there. That's good. But now, if I hit Command Space, the IDE doesn't really know. I'm going to actually enable auto import here. The IDE doesn't know about the site extension. Whoa.
Yeah, tried to add something completely different.
Yeah, that's no good. And so it's a lot easier to make a mistake. You don't really know, output nothing. So you can kind of see in general how much of a difference the Kotlin DSL can make just when you're authoring these build scripts. All right, so one of the questions that I get asked all the time is, should you adopt the Kotlin DSL? And first of all, there's a few prerequisites that we think really you must follow in order to adopt it. You've upgraded to Gradle 5.0 already. I would not suggest upgrading to Gradle 5.0 and Kotlin DSL at the same time. You need to break problems down like good engineering. Using the plugins block sets up the proper class paths and things so that the IDE can give you experience. If you're using the build script block, the IDE can't really help you because there's too much reflection going on. Are you using an IDE that has Kotlin DSL, Gradle Kotlin DSL support? And I'll show you a table on the next slide. And finally, if you're familiar with basic Kotlin syntax, it's not all that different most of the time, but you can't use single quotes anymore. And you have to know how you will migrate to the Kotlin DSL if you're using Groovy right now. You can migrate incrementally. So what we usually recommend is converting your root build script to Kotlin and then using apply from syntax to apply your Groovy build scripts from your root build script. And that way you don't have to convert all at once, especially if you have a big build. So just to note on IDE support, if you're using IntelliJ, make sure you're using 2018.3. This was released just this past week. That has some really crucial bug fixes that make the IDE experience much nicer. Android Studio 3.3 RC and higher. 3.4 of course, but if you're using 3.2, you're just going to get syntax highlighting. It might not give you the assistance. Same thing with Eclipse and NetBeans and some other major editors. You'll get syntax highlighting, which is fine, but you're not going to get the refactoring tools that you would expect. And so we're working with BuildShip and others to add better Gradle Kotlin DSL support, but that's still pending. So you should wait on that. Again, if you've tried Kotlin DSL already, I'll admit I think it was a bit rough even a couple versions ago, and everything's really come together in Gradle 5.0. So it's time to give it a second look. If you've tried it, and give us feedback on the Kotlin DSL issues. If you're interested in learning more, then we have a Kotlin DSL primer for you on Gradle Docs. Go to docs.gradle.org, chapter Kotlin DSL. Use that link on your screen, or you can just search in the docs now. So yeah, that's all about the Kotlin DSL. It's super exciting. Again, and I want to clarify one thing. If you like the dynamism of Groovy, that's fine. We're not going to deprecate the Groovy DSL. We just want an option that also gives folks, allows folks to opt into the static typing and stuff. But we're not going to replace the Groovy DSL with Kotlin DSL. It would have to be called a different tool.
Yeah, I mean, we see that in the knit plugin. Like, you still have the option, like there's Groovy and Kotlin. All of our examples in the docs have the 2-tab thing that you added.
So Groovy's not going away. But with that, that's pretty much all I have about the Kotlin DSL. So we want to take a few minutes to answer your questions. All right, what's DSL stand for? That's a domain-specific language. And Gradle's developed with a sort of domain-driven design in mind, and so the domain is software development in this DSL. And to learn more, by the way, about Gradle, if you're not really familiar with Gradle, you should check out intro trainings at gradle.org/training.
Yeah. So the question then is, have to ask, how did you get the Nyan Cat as your progress bar? So this is actually a plugin from IntelliJ. So if you go to the plugins you can download, you can find it there and install it. So are plugins made with Groovy compliant with the Kotlin DSL? They
can be. However, we recommend accepting actions instead of closures. So make sure that you have action overloads when you're accepting input. Because if you're configuring with closures, those are Groovy closures, and then the Kotlin DSL, it's really annoying. Let's say it's just ugly to call to make Groovy closures. There's a with Groovy DSL block that makes it easier. So I mean, it can be done. It's just that it's harder.
And that's in the documentation, right?
That's in the documentation, yeah.
So let's skip to this one. What guides can you recommend to convert to the scripts? So there is a migration guide on guides. Was it guides.gradle?
Guides.gradle.org. There's a migration guide, as well as and starting with that Kotlin DSL primer, that will give you prerequisites like what I told you about the plugins DSL, when you apply scripts and stuff like that. That way you're not jumping into something that is going to cause you pain while we make sure that we make the Kotlin DSL accessible to more and more people. So yeah, someone's asking if the Kotlin DSL is stable, and indeed it is. Like Gradle 5.0, it's now considered stable, which means that we're not going to introduce backwards compatibility breakages until Gradle 6.0, which won't be for at least a year. And so yeah, we have had a couple of breaking changes we had to make in 1.0 RCs, but those are done now. We have a deprecation cycle now, as with all our other features. Okay, so someone asks if future versions of Gradle could gain similar benefits in Groovy using compile static. Yes, this is actually a result of the plugins themselves. It can help a little bit, but there's so much dynamism in all the constructs all the way down that we can't make it a consistent experience. Kotlin makes that, sort of enforces the static typing. And so you can gain a similar experience with Groovy, and we really tried. I mean, it was, we introducing a whole new DSL it's a lot of work, and we wouldn't have done it if we didn't think it was absolutely necessary and worth it.
So we'll continue on then with build performance when you're ready.
Yeah, sure. So not only in Gradle 5.0, but there's also been some recent releases of Gradle that have introduced some really great performance enhancements. So just upgrading to Gradle 5.0 will give you a bit of benefit. So for example, with configuration time. Here you see a couple of charts which from our performance test suite, which show a 1,000 module Java project, which has, I think, like 10,000 source files. And this is these graphs are for incremental compilation and configuration of a Java project of this large size across recent Gradle versions. And you can see with the green bars, Gradle 5.0, we've decreased configuration time and incremental compile time by a significant percentage, 20%. And this is a result of some optimizations we've made for like specialized data structures, and I know we also probably optimized serialization and some other aspects that bring this down. We want configuration time to go to 0 because you see, configuration is Gradle compiling your build scripts. You have to recompile every time your build script changes. We want that to be 0, and that's why some of the APIs I'll show you later also try to reduce this configuration time even further. Another big thing that we added in Gradle 5.0 was incremental compilation for Java by default. Incremental compilation has been around for a while in Gradle, but we really made some great strides and turned it on by default in Gradle 5.0. What we've done enough memory optimizations that we've reduced the default heap size for the Gradle daemon, worker processes, and the Gradle client by more than half in all cases. And not only will this, it makes Gradle less memory hungry because it's much more optimized. You'll be able to also now run Chrome and Slack at the same time you're running your Gradle builds. The incremental compiler has gotten much better thanks to the work of Stefan Oma and Mark and others. And we're now really proud and glad it can be on by default. But to take full advantage of the incremental compiler, first of all, you want to make sure that you aren't mixing your sources in a single source set. What this means is putting Java sources with your Kotlin. In source main Kotlin, you have Java and Kotlin, or same thing with Groovy. The reason this can kind of negate incremental compilation is that Kotlin's incremental compiler, Gradle's Java incremental compiler, it has to do a whole lot more work. It still works if you put these together, but it can infer a whole lot less because it doesn't know, hey, is there a Kotlin file that depends on my Java source that depends on my Kotlin? Like that gets complicated because it has to, each time it's, since these are both JVM languages, it has to do all this extra checking. When you have your separated source sets, the Java under source main Java, Kotlin under source main Kotlin, it can infer a whole lot more, and that allows for better incremental compilation. So yeah, that's a big pro tip. I've seen projects that have reduced their compilation times by a factor of 10 just by separating source sets. Another thing that you'll want to do to maximize your use of incremental compilation is to update your annotation processors. Gradle 4.7 introduced incremental annotation processing. That means incremental compilation in the face of annotation processors being present. And so over the past few months, major annotation processors like Dagger and Lombok and others have updated the libraries to opt in to incremental annotation processing. And so once you've upgraded to Gradle 4.7 or higher, probably 5.0, because there's actually new APIs in 4.8 and further that make incremental annotation processing useful in more areas, then you'll update those libraries as well. And we're working with other library authors, or if you are an annotation processor library author, we ask that you continue opting in to the annotation processing APIs so that Gradle can give all these folks faster builds just by upgrading the library. Build caching. Again, not super new. It's not a new concept, just like the Kotlin DSL, but it gets even better in Gradle 5.0. Let me tell you a little bit about what I mean. But first, I want to give you a little overview, just to remind us why build caching is important. So right here, I have a little animation with some terminals. On the left, we have a C build with the build cache off, and on the right, build cache is enabled. And you can see that the write is obviously much, much faster. And that's because you could see two tasks, the compilation tasks, were resolved from a build cache. Now, build cache allows you to resolve previous outputs from any build, not just the most recent build, but also from builds from other Git branches, builds that if you have a shared remote cache, if your CI compiles the same Kotlin or Java, downloading those compiled sources, the compiled class files and stuff, is going to be much faster than recompiling them yourself. And so not only is the build cache applicable in many more situations. For example, now when you have multiple output files and multiple output directories, caching is not disabled anymore with your custom tasks. If you use like the @output files, it's available. There's also in recent versions better error checking to make sure that you don't do something that inadvertently invalidates the cache. And by the way, the best way to debug this is through a build scan, and I'll show you later. I forgot to mention. So if you're using the build cache, you should upgrade, obviously to the Kotlin Gradle plugin, Android Gradle plugin, Scala, Jacoco, Antler. There's some others that have adopted the build cache recently. And so you'll want to make sure that you've updated those plugins as well when you upgrade to Gradle 5.0, because those will opt into the build cache and make it much more effective. Let's talk a little bit more about a different part of your build process, which is testing. Testing often takes the most time out of when you're running builds, especially those integration tests. So a new option that was added in, I think, Gradle 4.6 was fail fast. So when you use --fail fast or fail fast when you're configuring your task, Gradle will stop after the first test failure instead of after the entire test suite runs. And furthermore, Gradle will now rerun failed tests first. So if you have a failing integration test and you rerun that same task, it will say, oh, I know that test A has failed, so I'm going to rerun that first. That way you have the quickest possible feedback loop.
That's important.
Yeah, especially for your development if you're trying to figure out one.
Yeah, I mean, I worked for a team that had hundreds and hundreds of integration tests, and I'd sit and I'd go get coffee while I was waiting for the thing to see if it failed, because it was test 400 of 500 or whatever that was failing.
And just imagine how much time folks are spending waiting, checking Reddit or whatever they're doing while their integration, their web tests are running. It's a legitimate, many $million problem.
Yeah.
We highly recommend you check out the Performance Gradle guide that shows all of these tips and more. This is your single best resource for optimizing your Gradle build, and I'll be very surprised, appalled, if you don't go through it and you don't learn something that makes your build faster. Okay, so someone asks if there are any performance benefits of using the Kotlin DSL. No, the Kotlin DSL performance characteristics are very similar to Groovy's. Kotlin DSL build scripts can be cached in the build cache, which makes subsequent uses faster than Groovy, but only marginally so. The first compile, the Groovy compiler takes a little bit longer with that static typing than Groovy does. So the first executions will be a bit slower, and subsequent executions will be faster in general. It depends on the app a bit. There are usually other performance benefits that you can get in other ways than converting to Kotlin DSL as I would make sure that incremental build caching, incremental compilation, all that stuff is done first before you consider the Kotlin DSL for performance reasons.
This is a good one. So does the build cache work on CI, in particular for Docker running on AWS?
Heck yeah, it does. So that's probably one of the biggest use cases for the build cache, is that if you have ephemeral build nodes, like on AWS where there's shared nothing, you don't have some cache directory, right? As long as it's connected to a shared build cache, it can go and download those resources from a shared cache, and that can significantly improve your build speeds, especially in these containerized environments. So, good question.
Okay, so one last question that I think is kind of important because it's one that we get asked a lot.
Okay.
So is the network build cache only available in Gradle Enterprise?
Okay, so I'm going to assume network build cache means shared build cache. The answer is no, you can use a shared build cache outside of Gradle Enterprise. However, Gradle does not provide good management tools for you, such as cache eviction and administration. So anyone can push to your cache. Gradle Enterprise gives you a bunch of really nice management tools that allow you to keep the cache at a certain size and make sure that only certain folks can push to it and so forth. So the answer is Gradle Enterprise is highly recommended, but we do publish a Hazelcast example so that you can have your own shared remote cache. And even if you don't have a shared remote cache, even turning on the local build cache saves you time, because every time you switch, say, Git branches from a feature branch to your master branch, for example, the build cache will help you out, because it's not just for subsequent builds, just like the up-to-date checking. It's for any build that you've done in the past. So anyway, hope that helps.
So if someone wants to find that out, they should go to Gradle.com and
/build cache, yeah. And they can see the benefits there for sure. And I mean, really, a shared build cache is. I'll tell you what I heard from Luke the other day. We've saved 62 days of build time over the past 24 hours from the shared build cache, like
just within the Gradle team.
Just within the Gradle team, and I mean, yeah, we run like a lot of builds, but we save like over 80% of our time because of the shared build cache. It's the single biggest thing optimization that we can make, and it's like it makes a 5-minute build a 1-minute build. I probably could not work at another organization that didn't have it. Like it's that, like I'm crazy spoiled.
Let's move on to dependency management, and maybe some of the questions that I see here will be answered. So as a longtime Spring user, I had to deal with a lot of different issues with dependency management and making sure that everything was aligned, my version of Spring Boot with my version of Spring RestDocs, for example. And so I usually did this using the Spring Dependency Management plugin. And I can talk about that, but I think the best thing to do is to actually show you what I did. So there are some changes that happen that happen when we go from 4 to 5. So the dependency management plugin was like the way to do things with 4.x because we didn't have native BOM support, or at least as good as it is in 5.0. And so what I mean here is that this dependency management plugin will help me use a particular version for these things that aren't declared. So Reactor test or the Spring Boot starter test, for example. And this can be really helpful. But sometimes what gets added by default isn't always helpful. In this case, I'm going to try to run this example. And if you were looking ahead, you probably saw the things that I was commented out and where I'm heading here. But there's an issue, which is that it collides with another dependency that I'm using. The error here itself isn't as important as the fact that I know that it's that we're going to get a different version of Groovy than what I need for another dependency. And so if I look in here, so this is a build scan. I think this is the first time we've looked at these here. We get all of these different things, but I'm not going to use that. I'm going to use search and find that my Groovy version got downgraded from 254, which is what I specified, to be 2413. And so and it says it's selected by rule, which is coming from something that I was using with the Spring package. So what I did, and actually, there was one more thing in here that we looked at before. Let's go back to dependencies. The way that the Spring Dependency Management plugin does this is that it creates a bunch of these different detached configurations. And if we look at the performance tag, which is one of the things that someone was asking, we can see that this is, even though these are like relatively small times, there's just a bunch of them and they're all adding a little bit. And so when we remove this plugin and use the native support, Gradle can be a bit smarter in the way that it's resolving dependencies and save you a little bit of time. And this is just like a little toy project that I use for demonstrations and talks. If we extrapolate this out into much larger projects, this difference is going to be a lot bigger for you. Okay, so that's kind of the way that things were. And so this project's already been upgraded, but I can, now that everything's in Gradle 5.0.
Right. So specifically, BOM support is now
stable. In particular, BOM support is stable and on by default. You don't have to use it. Like there was a thing where you had to like turn on a flag, and now it's anyway. So I always go back to the documentation, and so the documentation is actually something that we should mention too. So there's a bunch of new documentation as well as expanded documentation for a lot of this dependency management stuff. In particular, this section on Maven BOM support, and so I'm going to copy this example from from the documentation directly, because that can never go wrong, right? And in this case, I'm going to change out, typing, of course. Change out this version so that this matches the version of Spring Boot that I'm using in my project. And so this is going to use enforce platform, which means that I want to force all of the dependencies that Spring Boot recommends onto this project. And then anything else that I have down here is going to, it's gonna have to go through conflict resolution to figure it out. But if there's something in the enforce platform, then it's going to use that instead. So what do you think will happen if I try to run this?
All right, so let's see. We're on the implementation configuration. We're importing a platform, enforced platform for this Spring Boot BOM, right? Mm-hmm. So I don't really know what versions of Spring Boot and like the transitive dependencies are applied here. So we'll see, but I do know that whatever Spring Boot wants it's going to have here, no matter what.
Let's see. Okay, so let's try and do this again. Okay, actually I should not have run. I should run dependencies, because that's really what I want to know.
Right.
Right. Okay, dependencies, search for Groovy. Test compile, we see that it's getting conflict resolution, but let's look at Spring. Yeah, so we can see it here, that we went from 214 here in Spock Spring. So if I try to run tests, this might be the one that fails. Yes, okay. So we got here again. Sorry about that. That this was what I was specifying. So sometimes enforcing the platform may not really be what I want to do. So I can instead use just regular platform, which will change these from requirements into recommendations. And so if I rerun this again, we'll get tests that should pass, because it's going back to the right version of Groovy that I want. And that is because I actually specify a different version of Groovy here, and extrapolate this out into a variable, which is 254, which I had mentioned before. Okay, yeah, so went a little faster. We're getting a little bit from cache. Build scan again, dependencies. Anyway, yeah, we saw that it worked. So obviously it's using the.
Yeah, if we search for Groovy, it'll show that it's the expect like exactly 2.5.14 or whatever, or not 14, but 4.
Yeah. So 254.
Yep.
And in fact, other things got upgraded to the version that I wanted to override it with. Okay. So the other thing that we kind of notice here is that a lot of these detached configurations have disappeared too.
Nice.
And if we look at the performance tab and the dependency resolution, we see that that might be one of the things
the cumulative
that's
time
slowing
spent
down.
resolving dependencies was much lower. We didn't compare from before, but 0.1 seconds instead of whatever it was. Yeah, there you go.
So that's a little bit about why importing from a BOM is nicer using the native support in Gradle. Gradle can make smarter decisions about what versions to use. You can still override them if you want to use it as recommendations rather than requirements. And this is like just one really small example. Of course, there are still lots of edge cases in the that the Spring Dependency Management plugin covers that we don't do natively in Gradle yet. But that's a great conversation to follow with that plugin on GitHub, as well as reading through all of the documentation that we have in the dependency management section, which I had created a short link for there.
Okay, so one of the key things I think about Gradle's BOM support, it uses this feature called dependency alignment.
Yeah.
And what makes this a bit different from Maven is that the versions are enforced transitively. Mm-hmm. So if a transitive dependency depends on the bad version or a version you don't want, that's actually conflict resolution happens transitively as well. And so you won't have issues where some transitive dependency pulls in the wrong, like logging binding or whatever. All of that stuff can be normalized. which is really what you want. And that's part of the BOM support that's in Gradle 5.0. So yeah, I think that's pretty awesome though. Like it's nice that you can debug to that level with build scans, like the dependencies, and see where things came from and why, and how much it added to your configuration time and all that stuff. And it's really fine-grained, and it even captures network activity. It told you that the dependency came from repo.spring.io, and that's really interesting information to know, especially if you're like, I expected one to come from an internal Artifactory server. That's really interesting.
Yeah, and this is like really just a simple example. This is just brushing the surface. There are so many more things that have changed with dependency management, and have gotten a lot better in 5.0.
Yeah.
So you should check it out,
Yeah.
and see how to improve your builds or when you upgrade.
All right, so time for questions. One question: are there plans for BOM publishing and generation from Gradle? Cedric tells us we will support publishing BOMs. I actually didn't know that. Today I learned. Thank you, Cedric, for chiming in and saving my butt there, like you always do. But that's good to know.
Yeah. But you should follow Gradle for more information on the timeline of that.
Oh, for sure. Yeah, following the Gradle Twitter channel also is probably a good way to keep on top of some of this stuff, because we like to announce things. So Java module system support. So Gradle 5.0 does not introduce any changes to the JPMS modules. You still configure that mostly yourself. Yeah, stay tuned for updates here. I'm not entirely sure what the roadmap is.
And there's a couple community plugins that you can try out if you want to.
Yes, that's right.
So what is the recommended practice for using dynamic dependency versions? And yeah, I don't like it as much, because you kind of, not lose control, but if you run into an issue where something is upgraded, like, the Groovy was from 2.4 to 2.5, so that was a little bit bigger jump, but not every dependency follows the same practices for like breaking changes in minor versions.
Yeah,
so I tend to
semantic
try
versioning,
and,
you're
essentially, yeah. Not everyone is great at following it. But if you want to, there's a good section in the documentation about that.
Yes.
And you should definitely use them with locking, which is what I was saying, that if there's an issue in a new version, that it won't affect you because you can lock at that particular version.
Mm-hmm. Yep, you write your locks. So moving on, new Gradle APIs. Yeah, there are a number of new things and recently added things that are exciting to anyone who has to maintain Gradle builds, and especially plugin authors. I'm just going to show you some of them live, but first I'm just going to list them out here, and you can look up the docs for them individually. So one of the most requested ones is timeouts, the ability for tasks to time out. So you have integration tests, and you want to make the Gradle stop after a certain amount of time because something got stuck. Some HTTP request got stuck, some database operation got stuck. And so now for any task, you can just you can set a timeout through the provider API. So you just say timeout.set, a duration, it's a java.time duration, and you can set it to whatever you want. And Gradle will just stop after that amount of time and fail to build. And super neat feature in Gradle 5.0. So I have a more complicated example using the configuration avoidance API here that I want to show you. So here we have a project where we're configuring the test tasks, and we're saying for all test tasks, we're using this .configureEach. ConfigureEach is a new configuration avoidance API. Gradle will run your configuration actions anytime you invoke anything on your Gradle build. So it evaluates your whole build script. ConfigureEach and registering tasks, Gradle will no longer run that configuration action unless that task is selected. So just to make this super concrete, you see this use JUnit platform here to use JUnit 5. This will not be run unless a test task is selected. So it will run if you run Gradle test. It will not run if you run Gradle help with this configuration avoidance API. So, and then just digging into that JUnit platform here, we're including the Spec2 engine for this Kotlin project, and we're also invoking this newish fail fast. This just tells it to always, this tasks to always fail fast, that you can apply in your build script instead of just your command line. So that's an example of a couple new APIs that we have going on here. And these are Kotlin DSL samples, so they're nice and kind of colorized and safe. Another thing that I think is really neat for plugin authors is custom command line arguments. You can define command line arguments like, in this example, you can define a custom output directory on the command line. So you can say Gradle my custom task -- my custom option output dir in this situation, and then you can give it a value, and it's going to always take a string. So what I'm doing here is creating a setter for my output dir property, and I'm declaring an option. An option is a command line option with output -dir, and then giving it a description so that when you call Gradle help -- task my custom task, it will show this option. And so now if I run, this is for the site plugin, Gradle generate site -- output dir, whatever, the output dir for that site is now customized on the command line. This is really neato for plugin authors again. Another one that I want to finally show you is the Worker API. So the Worker API was introduced a bit ago, but we need to see more plugins adopting it. I hope you folks will, if you have custom plugins, will consider adopting the Worker API, because what it does is it isolates the work done in your Gradle task actions so that it can be run in a separate process. So it can be run in a worker daemon with like an isolated class path if needed. And what this does is it allows safe default parallelization. And so just to show you, it's not hard to adopt the Worker API. What I've done here, the key line here is this, we're running this free marker site generator here. And what I've done is inside the run method of this site generator runnable, this is taking all of the inputs, the project descriptor, the links, and the output directory, and it's running the site generator. And then we submit this runnable to a worker executor that we inject to our custom task. Okay, that sounds like a lot, but check out the Worker API guide, and I think it'll make a bit more sense. And then we configure that worker executor with configuration that sends it these inputs. And again, the important thing is that it takes that long task that can significantly increase total build time, and it can break it up. There's different ways that you can parallelize things, but it can break tasks up into separate pieces, and it can also make it run so that instead of everything being on one line, it runs this task in parallel, and it reduces that critical path. Give the Worker API a shot. It's pretty nice. I recommend it. Yeah, that's just the highlights of the new APIs that we have in Gradle 5.0. And there are more. We just touched on not even half. There's a whole lot that are documented, and we cover even more of those highlights in this page, gradle.org/what's new in Gradle 5. Yeah, along with all the other content that we presented today. Much of that is on that page as well.
Yeah, and I mean, still a lot of questions about things that hopefully we'll be able to get back to you soon. Mm-hmm. And yeah, so I guess we can do the wrap up, and then we'll take the last of the questions, mm-hmm. and work from there. And if you want to learn more about Gradle in general, maybe follow up with some of this stuff, Gradle.org has a trainings page, and there are like basic intro to Gradle, as well as some deep dive sessions from time to time. Yeah,
every month we have some kind of training going on, many, even a few per month. So you can get an introduction or advanced training.
And some of the things that we showed, particularly with the build scan features, are part of Gradle Enterprise. So of course, please take a look at that as well.
Thanks for listening, folks. We'll start taking some questions, but we hope you enjoyed. We hope that you thought this was informative, and yeah, give us your feedback and hit us up on Twitter at Gradle.
Yeah, we definitely prefer questions on the forums.
Sure, yeah. Especially if it's going to take more than 140 characters. Yeah. So let's take some questions.
Will there be training for the Kotlin DSL? That's a good question.
I think you can expect some training updates sometime where we'll start showing off the Kotlin DSL. But for now, the Kotlin DSL primer and the migrating from Groovy to Kotlin DSL guide are going to be your best resources by far. And remember, like, we updated the docs in Gradle 5.0 so that every example has a Kotlin DSL variant. So you'll be able to find a whole lot there. And there's even some samples on the Kotlin DSL project itself. There's sample builds.
And there's lots of talks and other stuff coming out soon too. So how is
task 7 split? So how you can split up work. The code sample that I show here actually just runs a single process out of process. So what this would do on that diagram is move task 7 to another line below everything else. How you split it up is by submitting multiple pieces of work. So just say imagine that you are writing the Kotlin plugin and you're compiling 1,000 source files. What you would do to split up a task is you would submit a piece of work for each subset of the source files you want to process, as long as they are mutually exclusive, right? So you would say, okay, for this 1,000 source files, I'm going to run compilation here, and so forth. Maybe Kotlin compilation is probably a bad example because each of these files actually probably depends on one another. But if you have tasks where outputs are sort of one-to-one or just one-to-many and not all interrelated, then you can break up these tasks. Like let's say you're writing the ASCII Doctor plugin. That's a better example because you usually have one ASCII Doctor file to one HTML file. Then you can split that up into as many worker processes as you want, or worker submissions. Now, it's not going to fire up a new process for everything it's submitted. It's basically a work scheduling engine is basically how it works. Yeah, sorry. Hopefully that was answered your question there.
So next question. Gradle Enterprise lists build scans as one of the benefits, but what is the difference between the free and paid version?
So the biggest difference is build comparison. So we didn't show that because it's not part of the Gradle build tool, but one of the big things is that you can compare builds with Gradle Enterprise. So you can have you can link to two builds and you can say, oh, why did this one pass and this one fail? And it will tell you in a very granular fashion, oh, this dependency changed, this transitive dependency changed, or the version of Java changed, or some environment change, like you ran it with lower memory. It does a whole bunch of like very fine-grained comparison for you. Another thing that's part of Gradle Enterprise that's not necessarily a part of build scans, but it's related, is dashboards. So like Performance Dashboard, for example, it collects all of the build scans together and shows you a trend. So you can say, oh, my build got slower or faster over time, and then you have a bunch of filters and analysis that you can do for all of those build scans, because the build scan data collects all that data and that you previously didn't have access to, right? It can tell you like, oh, your builds have gotten slower because someone added Scala or they added an additional repository or something like that. You'd never, otherwise the frog would be boiled. You'd be like, oh, like it seems slower now, and then you'd have no way to quantify that if it just feels slower. My coffee break feels longer or shorter, and you don't know why. Yeah.
One of the other things that's different is some of the security and privacy things. So when you run build scans publicly, then like if you go to any of the links that we showed on any of our examples, like anyone, including you that's out there, can go and look at those. But if you are using build scans for something private and you want to host it in your network or any of that stuff, you should use Gradle Enterprise instead of the public instance.
Right. Yeah. I mean, you can delete build scans, and I mean, we would never like do anything with your build scan data anyway.
Right.
But yeah, if you like absolutely must keep all project information within a certain network, then using self-hosted Gradle Enterprise is no question the way to go. But again, want to thank you for attending, and hope you enjoyed it. And
until the next one.
All right, take care. This is Eric signing out. See ya.